before we get started implementing all the plans from the previous video, let's just go through the code analysis and see what warnings we actually got, or at least that I got. So from our game activity, I see that I have some unused import directives. Can I double click there? Yeah, here we go. So if I right click, can I get a quick, there we go. Optimize imports, thank you. Redundant modality modifier. Yes, apparently final probably is redundant with val, because val should be a constant anyway, so final is a Java leftover. I don't need that. We can look at the next class, which is, let me remove that. In the main activity, we have a redundant semicolon, and that's because I come from other languages, so I can remove that. And now, can I refresh this panel, or what do I need to do? Well, we've addressed them. Let's go back to the game activity. We made a bunch of plans, right? We need... No, not the game activity. Let's go to the game. That's where the plans are happening. We need a thread to execute our run function. So let's create one, at least a member. Now, it should not start until the lifecycle callback comes in and gives us a go-ahead sign. So we need this to be a late init variable. We're going to call it, I don't know, game thread is good enough. It's of type thread. There we go. Okay. Resume comes in from the system. I'm going to rename this because resume isn't particularly clear that it's supposed to be a callback. In Android, on something is a callback. So I want to right click, refactor, rename, and I'll call it on resume instead, just like the standard classes do. So right click, refactor, rename, on pause. I need to make this modification to clarify a point with all of you as well. You never call these functions yourself. The callbacks, on pause, on resume, on create, on stop, they are called by the operating system. They are not for you to play with. You just get notified that something is about to happen to your app. You get to pack your bags, ready your stuff, prepare for whatever is to come, and then the operating system will do its thing. So never call a callback from your own code. I say that, obviously, looking at an example where we do exactly that. We get on pause. We are now in the game activity, right? So this is a class that listens to the callbacks from the operating system. The operating system tells us on pause is happening, get ready. And what we then do is we call something called on pause in our own class, so that we just forward the notification and let our game logic deal with whatever it needs to deal with. And then we call the system default behaviors for on pause from the class we inherit from by default. So outside of these functions, do not call callbacks. It becomes very weird when you start messing with the lifecycle on your own. Only the operating system gets to do that. Back to game. We have a game thread. Let's see. Let's start with on pause then. So we need to join the thread. We need to stop it. And that means we also need our flag. You remember our run function. While is running, update the game state, render the game state. So we call that a variable is running. It's a Boolean. I'm not sure if we have to say that because we assign it false immediately. So by default, the game is not running. In on resume, we start with setting is running to true because we're now about to start up. We then make sure that our game thread is a thread. Let's see. That takes our class as an argument because our class is runnable. That's what a thread wants. And then we tell the thread to start. Let me zoom in a bit in case you can't see. So on resume, first set the game logic flag for is running to true, then create a new thread and start it. We always create a new thread because you cannot reuse threads in Java. If the thread has been joined, it is gone forever. So create a new thread and be happy. What's the opposite of this? We want to join the thread and stop the game from processing. So we need to set is running to false again. And then we want to tell the game thread to join. That's thread speak for do your thing, and when you next get to a breakpoint, make sure you leave and stop. So it won't stop immediately. It will stop whenever it gets to the end of this function. And this function is a near infinite loop. We can rewrite the pseudocode that we have now. So essentially, while is running, open the braces. This is all the gameplay code. We want to call something called update. We want to call something called render. This is the core loop of most, at least, basic games. You update the game state, make sure that all the objects, get to move to where they need to go. They process collision detection, whatever. All updating of the game state happens first. Then we render. And ideally, the render pass changes nothing. The render pass should be able to be all const. That's really helpful for many, many reasons we'll probably not need to get into at this point. But we only change stuff during update, and then we draw stuff to the screen. Now, these functions don't exist, so we can right-click. We want to... No, let's just do context actions, create that function. And here, show context, create the render function. So, core loop, and then render and update core gameplay functions. What needs to happen in update? We need to update all objects. I'm going to call them entities. Game entities is a fairly common term. And that's it. That's what needs to happen. We want to make sure the game state is where it needs to be. Render, we need to... This is a bit more complicated. So yes, there is a loop. We want to draw all entities. But first, we need to lock and acquire the surface. So we want to lock and acquire a surface to draw to. Acquire is not spelled like that. Draw all the entities, and then we want to unlock the surface and post it to the thread, to the system. The reason we have to jump through these hoops is essentially that we're dealing with inter-process communication where the operating system provides us with a buffer from the surface view. We're going to need to touch that buffer and do things to it. The operating system also needs to access to that buffer. They need to be able to draw from that buffer. And we need to make sure that we're not editing the buffer while the operating system needs to draw from the buffer, because then the result will be undefined. Instead, what we do is we signal that right now I need the buffer and you cannot touch it until I tell you it's done. So we try to acquire a lock that we will hold for the duration of drawing all of our entities. Then we can unlock the surface and notify the operating system. Whenever you're ready, take this and draw it to the screen, please, for us. Before hanging up, let's just quickly add some logging and make sure that this works the way we think it does. So we'll do a private val tag. We call it game. Then we go to say we want to do the callbacks. We can do update and callbacks. So let's log d our tag and update. Oops, sorry. We need to import this class. Alt enter to quickly do that. Then in our on pause, we're going to do log d on pause. And we want to do on resume. Now, we should know logging, first of all, is very slow, and updating right now, it happens inside of an empty loop. We're doing no work except for that little log call. This means our CPU, at least the core that we are running this thread on, that core will be pegged at 100%. It's going to be infinitely busy just spinning this loop. That means you can have a couple of effects here that might be unintended. One, the system might believe that your app has hung. It might crash. That's possible. That's expected. You might also see missing log messages. So since there is no synchronization with the screen updating right now, there's no no, yeah, there's no synchronization. This will just spin as fast as it can, and that isn't very good for anyone. Like if if an application does that, you will run out of battery really, really fast. The CPU, especially battery powered one, you just don't want to waste performance in that way. So our game will, by virtue of this locking and unlocking of the surface, the here when we post it to the system, there will be a wait. So we will wait for the system to draw to the screen before this function continues, which means our entire game loop will be synchronized with the updating of the hardware screen, which tends to happen 60 times per second or 120 times per second, which is far slower than what this loop will spin right now. Sorry, let's not. Let's just run it. And while that's compiling, I need to clear this logcat window so we can see what's happening. My emulator is over here. I want you to just be a small thing here. We start the game. There should be output, but there is not. This is interesting. We go back. We launch. We open. Nope. Okay. Let's see what I have missed. Our game activity. The game is created in onCreate. We have the set content view. We call onPause with interesting, okay? Our game has an onPause that are not triggering, or I'm not looking at the logcat because I'm a moron. There we go. It is very much triggering. Phew! I was surprised there for a while. Okay. So we can see the logcat spammed with messages. It's very likely that in your implementation, you might see these being aggregated. Logcat will filter out repeated messages. So if you only get a few updates, that's still possibly correct. Now, I drop out to the operating system. We do not get that on resume the way we should. This game is now running in the background, which is horrible. That's absolutely not supposed to be happening. And so unless the log is just, no, it's not. That's absolutely running in the background. Terrifying. So we need to figure out what's happening. I have a theory. Let me see. My theory is, oh, look at that, it stopped. That's good. Let's see. What do we call it? On pause? So on pause does happen. On resume does happen. Let's see. My theory is this. We need this thread to check is running. Is running is a Boolean flag of our game class. And before we pause the thread, we do set, here we go, on pause, is running to false, and then we ask the thread to join. However, it is likely that the thread, not the thread, but really the CPU is caching this value. So it's not being updated when read from the other thread. That thread is reading the same value over and over and over again. And instead of fetching the value anew from RAM every single time through the loop, what is likely happening, I think, is that it's optimizing it. So it knows it's reading the same value over and over and over again. It only needs to put that in CPU cache instead of fetching from RAM. And so it takes a while, possibly it never happens, before this thing updates. In C++, we have a concept called volatile to ensure that the CPU fetches fresh from RAM. And in Kotlin and Java, I'm pretty sure there is a similar concept. In Kotlin, it would be an attribute. Let's see, it's a volatile. If we declare this value volatile, the CPU should be forced to fetch it from RAM. So this is my working theory. And at this point, I'm keeping my fingers crossed that we solve this bug. Let's bring, there we go. Here's our emulator. We go back to logcat so we can see the output. Bring that up. We clear it. We might want to do my space shooter as a filter. I hope that's not wrong. And so now when I start, we should get first on resume to start the game, then a bunch of updates, and then we back out to get the on pause call. So we start that, We go back. That is... Oh, it did pause. Here we go. Okay, so, interesting. It is behaving correctly. It's just not as... now, at least, it is behaving correctly. Let me see if we can find our... let me see if I can scroll back far enough, in fact. Because I am a moron. Up to that, no. Okay. But we know that the thread doesn't start until resume is called. So we know that that's happening. Let me scroll this down. So we see that game on resume is logged. It starts the thread. Good. Then back to the log. We scroll back up to where it stopped. Here we go. So we have update, 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 1,000 of them every second. And then at some point, on pause comes in when we back out of the application. On pause sets the flag, and the thread gets to know that it's time to kill itself, and we get one more update, which is exactly right. So we changed the flag. Sorry, that's on resume. Here we go. Set the flag to false, which means the loop, depending on where it is currently during its execution, it might still have one check. What I'm saying is it is completely normal for the loop to do one more round after we see this message. That makes sense because it will not stop until we get back up here to see if it's time to leave the loop. Now, we could change so that on resume is instead printed. Sorry, not on resume. What am I? Here we go. On pause. If you want to avoid this little discrepancy, you can have on pause happening after the thread has joined. And that way you shouldn't have a redundant output. It's just a risky thing because, of course, if we're stuck in an infinite loop, you will never see this this log, and so you don't know if the callback has happened, yada yada. Troubleshooting is fun. And this is, of course, not a problem or a trouble at all. It's a behavior we can expect and reason about. So we clear the logcat again. I just want to make sure that this change does what I think it did. We go back to the operating system. We should see a pause here at some point. There it came. And scroll. That's a crash. Is that from us? Nope, that's from the network. This is good too. I think I've mentioned this, right? Logcat is full of stuff from the operating system. Do not troubleshoot errors that are not from your code. Literally, your code is what you need to debug. The system code is not yours. So this error we can ignore because it's not from us. It's the Android stack somewhere. I don't care. Let's see if we can do MySpace Shuta, so I don't have to scroll so much. Here we go. So update, on pause, and then silence. Perfect. That's exactly what we want. So handling the lifecycle is absolutely mandatory. Your game cannot execute in the background. After on pause, it should completely stop, not eat any battery, not eat any resources. At this point, I'm happy, so I'm just going to go commit all those changes. What have we done? Added the game thread and some unnecessary logging that we will clean up later. Let's look at the code analysis, redundant semicolon. I keep doing this. Right. So the trick was make sure that your thread flag is volatile so that the thread always checks a fresh value. Otherwise, it can become blind to the fact that it needs to stop because it might have a cached value in the CPU cache instead of reading from RAM. Good lesson. Nice. See you in the next video.